Hi, I'm Carl Franklin. In this episode of Blazor Train, I'm going to revisit handling application state in Blazor for .NET 8 and .NET 9. Application state, or app state, represents collectively all of the variables, objects, lists, etc., that you keep alive in your application while in use. Managing and persisting application state in Blazor on .NET 8 and .NET 9 is coming up right now, right here on Blazor Train. Yes, I said Blazor Train. What?
Blazor Train!
So the key to application state is to move it to a component that lives outside of the pages, so that variables persist between navigations and page refreshes, and variables can be shared by all pages and components. So we're going to create a component, and the goals of this component are we want the UI to automatically update with binding whenever any of these properties update. And we also may want to get control when the state gets mutated. So I'm going to create a new Blazor Web App. It's going to be called App State Server. Now, I have versions of this demo in different GitHub repos for WebAssembly and auto render mode, but it's the same code. When you go to the repo, you can select links for those other two repos. Now, this is the additional information. The demo will work in .NET 8 or .NET 9. We're going to choose .NET 9. No authentication. Interactive render mode is server, location global. Now let's observe the default behavior of the counter page. So I'm going to go to Components, Pages, Counter. And so notice that I've got this variable current count inside the code block of the page. Now, anytime you have a component level variable, which is what this is, it will get reinitialized to its value every time the page or the component gets initialized. And so this isn't going to stick in between navigations. Watch. All right, so we'll go to the counter page. We'll increment the count, which is great. Go back to another page, and now that counter page is out of memory, right? If we were implementing iDisposable, we'd have a dispose method that would fire. And we go back to counter, and the whole thing is reinitialized again because that variable is a module level or class level, or in this case, component level variable. It gets reinitialized. So if you wanted to, you could just create a class, call it AppStateCS, call it MyStateBag, whatever, and inject that, add it to dependency injection as a scoped service, inject it into whatever pages you want, and that would essentially do what we want it to do, which is keeping the data outside of any page or component. But I'm going to do it the Blazory way because I think there's a lot of benefits to doing that. We'll talk about those. So I'm going to add to the components folder a cascading appstate.razor component. Now, there's nothing special about the name Cascading App State. It could be called anything, but I like to call it cascading because that tells the developer, hey, this is going to be used as a cascading parameter. All right, so in the markup, you have a cascading value where the value is this, meaning this component. And then inside it, we're expressing @child content, which is of the type render fragment. Well, what's a render fragment? A render fragment represents a chunk of Razor markup that can then be rendered by the component. And in this case, what we're doing is capturing our child content as a render fragment, and we're going to render that content as part of our component rendering. But what is our child content? Well, let's go to routes.razor. And this is the router. Now, the router is the thing around every page component. This is essentially the list of all the components and pages in your Blazor app. The router looks at the route like /counter, looks at all the routable components which have the app page directive and says, you want to go here. And so then it loads that up. But if we surround it with cascading app state, now the entire application becomes our render fragment right there. Now, how do we access this cascading app state in another page or component? Well, I'm going to add a component called toolbar. And the toolbar is going to sit up top, across the top where the About link is now. And this is how I access app state. I specify a cascading parameter, and here's my variable app state. So the cascading parameter is essentially bringing the component in as a scoped service, except that it's a component. So this would be analogous to injecting a scoped service, but in this case, we get the one instance, because it's scoped, of app state that belongs to me, my user. And since there's only one instance of cascading app state, what I'm essentially doing is injecting it. But remember, it's the Blazor way to do it. Okay, now let's put the toolbar up in the main layout, right where that About link goes. So across the top. Now, anywhere we modify app state message, the toolbar is going to show it. Why? Because in cascading app state, whenever the message or count property is set, we call state has changed. So let's go to the home page and give it the ability to change the message. So when I click my update message button, here's my cascading app state. I set app state message to updated at the current time, and the toolbar should reflect it. Here we go. Boom. And anytime we update that message, it's going to show in the toolbar. All right, let's do the same thing for the counter. So everything's the same here, except increment count updates app state count and shows app state count. And now because that count value is outside the page, it will persist between navigations. Here we go. 1, 2, 3. Go to home. Hey, why don't we just do that too? Now, so far, we've handled the situation where multiple components that access app state properties can update their UI automatically when one of those components changes an app state property value. But what if a component needs to take action when a property value changes? For example, the toolbar might want to send a message, make an API call, or something like that. Well, one option is just to handle all that stuff in here when a value changes in app state itself. But we might not want to give the app state component such power over the application. In general, we should adhere to the single responsibility principle. After all, app state is just a state bag. It's just a place to hold data. We don't want it to be our entire application. Now, you could use iNotify property changed, meaning you could create an event, a property changed event. Components that want to be notified will subscribe to that notify property changed event, and then they have to use iDisposable, the dispose method, to unregister themselves. And in a previous version of this code, I created a pub/sub mechanism with event callbacks. It didn't turn out to work too well. And it still required the dispose method to unhook the callbacks. So, I'm not a big fan of, especially in Blazor, using iDisposable if I don't have to. And so I came up with a simpler way to get notified of property changes. The way we're going to do that is when a component is initialized, if that component wants to monitor app state changes, it gets a copy of the values of the app state properties. And then in onAfterRender, we can simply compare the app state property we want to monitor to our local version. And if they're different, boom, it's changed. And this is a really great solution, I think, because it doesn't require iDisposable, doesn't require callbacks. Like, you already have a callback in the form of onAfterRender. So let's use it. Well, before we can do that, we need to create an interface for the properties that we want to monitor. So for this, I'm going to add a class file to the project called iAppStateCS. So now I'm defining both of my properties in here, but you don't have to. If you only want to monitor a couple of different properties, then you could just put the ones you want to monitor in here. Because remember, this is just for checking changes. However, coming up, we're going to use this to persist the values of app state in between application runs. But for now, let's just do this. Now, I can't deserialize to an interface, and I can't deserialize to myself, so I need an implementation of iAppState, and we'll call it AppStateCS. Clean and simple. Now, to make the changes, I'm going to change this cascading app state to use a code behind file rather than this code block. So let's get rid of the code block. And now I'm going to add to the components folder a class named cascadingappstate.razor.cs. And you'll see how Visual Studio automatically knows that this is related, so it adds it to the hierarchy. Now, let's change the code. Okay, so in order to have a code behind file, it has to be a partial class with the same name, inheriting component base, and implementing iAppState in this case, right? So the properties are the same, message and count, but we've added this getCopy. So getCopy uses the interface to get an iAppState version of myself, then serializes that to JSON, deserializes that to AppState, and returns it. So this is a deep copy. Now I'm going to modify the toolbar to show how this is done. So I've got a private copy of the AppState data, iAppState state. On initialized, I'm going to call getCopy. And then in onAfterRender async, I just compare them. So if AppState message is not state message, and this is really important right here, you want to set state message to AppState message. So now they're back in sync. But in the meantime, you know that the message has changed. So you could do something right here. All right, so I'm going to put a breakpoint right here. And let's run it. Modify the message. Boom. We get control. Now, why does this work? Well, it works because in cascading app state, anytime we modify one of these properties, we call status changed, which forces a re-render. The toolbar renders, and we check. See? A simple way to monitor app state changes. Now, what if you want to monitor state changes from non-UI components? That is, components that don't have any UI, but they're still components that can be initialized on a page. There's a use case for that. So a component that provides access to back-end services via API or other mechanisms, wrapping that code in a component gives you access to all the component-y things like cascading parameters, event callbacks, and other features. So the good news is that as long as the component is instantiated on a page, the onAfterRender method will be called, even though there's no UI. So to demonstrate this, I'm going to add a component called hiddencomponent.razor. Now note, it has no UI, no markup, but it still has access to the app state cascading parameter, and we can still get control on after render, even though there's no UI. So let's go to home, and let's put a hidden component right here. We got our breakpoint in hidden component. Now let's check it out. Boom. Now, what are some other use cases for this kind of component? How about something that just wraps JavaScript? Right? You got a bunch of JavaScript out there that you want to do. I've made components like this in the past. So they need to be able to communicate with JavaScript, and you need to be able to place them on your pages and maybe even get a reference to them so you can access them that way with code. All right, now let's talk about persisting application state. It would be great if we could save certain properties. Maybe that's why we did that interface, huh? So that they'll come back the next time the app is run. So here's a scenario. You have a large set of input form fields that the user needs to fill out. After meticulously entering 99% of their data, they have to take a phone call or something, during which the form times out, or the computer reboots, or some other issue forces them to refresh the page. All that work is for naught. But by keeping their form values in app state properties and persisting those properties to their local storage area in the browser, we can retrieve the values the next time they log in. What's more, we can keep track of other data, such as what page they were using, or any other session-scoped variables that we'd like to persist between sessions. In this example, we'll also implement a time window, after which we will not reload their app state properties. Another option would be to ask the user if they'd like to continue where they left off whenever they log in, and only load if they say yes. Now, we're going to need access to local storage. And because this is a Blazor server app, we can use protected browser storage, which will encrypt the data for us. So I'm going to go to Program and add this. Builder.services, add data protection. Now, in order to do that time window feature I was telling you about, we have to add a field to our iAppState interface and implementation. So last storage save time. We'll also add that to our implementation. Last storage save time. Now I'm going to add a load and save method to our app state code behind. All right, I've got a storage key here, which we need in order to get the value. That can be anything you want. It can be in config, doesn't need to be here. I've got the storage timeout in seconds. So in this case, it's going to be quick because it's I can't make you wait for 5 minutes while we test this out, right? 30 seconds is enough time for a demo. You might want to extend that to days or even weeks or whatever. We've got a loaded variable, which I'll show you in a minute. Here's our last storage save time, which is part of iAppState now. We're injecting protected local storage. And we have our child content, and now we have some new stuff here. Anytime we mutate, after we force the re-render, we're going to save to local storage by calling save. And we're going to call it asynchronously. And this is a nice little pattern, if you've never done this, in a property handler to call something asynchronously. So let's talk about load and save. On the first render, we're calling await load and saying loaded equals true. Here's our get copy. And then save, we're calling, of course, from the property setters. So if we're not loaded, we're returning. That's why we need that Boolean. We set the last storage save time. We serialize. And then we set that value into local storage with the storage key. Simple. So now anytime message or count gets changed, the value of those will get persisted. Now load is a little bit different. We're calling in a try catch, you want to do that. Local storage get async of a string, the storage key, that's the data, that's the JSON data. Then we're going to try to serialize that to an app state. And if it doesn't come back, now we want to check to see if we're within that time window. And if we are within that time window, you could set the values manually if you want to, or you could use reflection. Still have that typo. So with reflection, you can go through all the properties, and any property in that interface that isn't last storage save time, you could set the value of our app state to it. And that's what we're going to do. But I have both options there for you in case you don't want to use reflection. All right, so here's the demo. All right, we update the message. Oh, we still have this here, breakpoint. Let's get rid of that. Update the message, update the counter, close the app, and then within 30 seconds, if we run it again, in other words, you come in within that time window, everything loads up. There's the counter, there's our variable, our message variable, and Bob's your uncle. And if I close it and wait after 30 seconds, and now we've forgotten that we have anything saved. So everything's back the way they were the first time. Now back to you in the studio, Carl. I know I mentioned this before, but I've created 3 versions of this repo for different render modes. I showed the server version today, right here, but I've also created a repo for WebAssembly and one for auto render mode. And I finally got rid of my annoying house guest. The quiet car at last. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time.
Blazor Train.